And welcome to Real House Engineering. In today's session, we'll be discussing about defuzzification methods. There is already a video regarding your total process of fuzzification and defuzzification, but in this video particularly we'll be discussing all about the defuzzification methods. Okay, so what is fuzzification? Converting the crisp input, okay, into fuzzified values is called as your fuzzification method. And what is defuzzification? Just the reverse, converting the fuzzified input values into your crisp output is called as your defuzzification method. So now let's discuss all the defuzzification methods in detail. So these are your defuzzification methods, that is your lambda cut method, Maxima method, centroid method and weighted average methods. So first of all, let's discuss lambda cut method. So what is the meaning of lambda cut? That means cutting at the value of lambda. So what is the meaning of that? Here I have taken a fuzzy set X and there are 4 elements inside the fuzzy set. Okay. And what is the lambda value I have taken? Lambda value is equal to, you can see 0.5. I have taken the lambda value as 0.5, right? And what is the criteria or the condition? The condition is X at lambda is equals to X whose values will be more than equal to lambda. Okay, inside the X lambda set, those values of X will be included whose values are more than equal to lambda. Okay, so let's check in the fuzzy set. In this fuzzy set X, whose values is more than equal to lambda. Lambda value I have taken 0.5. Okay, so X1 value is 0.5, so it is more than equal to lambda, so this value will be included. Okay, X2 is 0.6, more than lambda, this will be included. X3 is 0.2, less than 0.5, this will be not included, and X4 is 0.8, obviously this will be included. Okay, so let's write the new fuzzy set X at 0.5. The new fuzzy set will be X1 will be included, so I will write X1. Okay, against X1 I will write 1. Why? Because this is included. Okay, next X2 will also be included because its value is 0.6. Against X2 I will write 1. Okay, next X3 will not be included because its value is 0.2, less than lambda, so I will write X3, but against it I will write 0. It signifies it is not included. Okay, X4 value is 0.8, obviously it will be included, so I will write X4, and against that I will write 1. So X at 0.5, what are the things included? X1, X2 and X4. So these are X1, X2 and X4 are included inside the fuzzy set at lambda value equal to 0.5. Okay, so this is about your lambda cut methods. The second method is Maxima methods. Now let's understand in detail what is your Maxima method. Okay, so here you can see I have, this is a XY representation of your fuzzy set. This is a XY representation. Okay, what is the meaning of Y? What is this Y axis? What it represents? It represents the fuzzified values. Okay, already I have discussed in the previous video what is the range of fuzzy value. The range of fuzzy value is 0 to 1, including all the values in between values of 0 to 1. So X axis represent your fuzzified value starting from 0 and this will end till 1, but here I have taken till 0 to 0.5 I have taken. Okay, so 0 to 1 and including all the values in between 0 to 1 is your Y value or your fuzzified value. And your X axis represent your input values, your crisp, whatever input values you will be given to the fuzzy inference system, whatever that input values is represented by your X axis. Okay, now is what, that this XY representation I have represented like through a fuzzy set. So I have taken a fuzzy set X and I have represented it in a set. So how I have written? First of all, I have written the 1, the input value 1, and against it I have written the respective Y or its fuzzified values. Okay, so 1, what will be its membership or fuzzified values? So if I draw a line, it will intersect at 0.1, so its Y value is 0.1. So 2 will be intersected at 0.4, so 2 value will be 0.4. 3 will be intersect here at 0.4, so 3 fuzzified value will be 0.4. 4 value will also be 0.4 because it is represented, intersected here. 5 value will also be 0.4. You can see 5 value is also be 0.4. and 6 value will be somewhere between here. It will be something like 0.1. Okay, so this is the way in which I have represented this membership function in a fuzzy set. Okay, and as what I have to do, as this is a Maxima method, so what from this fuzzy set we have to select the elements whose fuzzified value or the membership value is maxima. So in this diagram, what is the maxima fuzzified values? 0.4. It is last, it is going till 0.4. Okay, so 0.4 is the maximum value. So we will pick all the elements whose membership value is 0.4. So we will pick 0.1 is not maximum. We will pick 2, 3, 4 and 5. Okay, so here I will write another element, that is x max. Okay, because it is containing all the maximum value elements, and I will write 2, 3, 4, 5 with its fuzzified values. Okay, so now this is a maximum method. So if I want to know what is first of maxima, what is the first element coming as maxima fuzzified value, so coming from x this direction, the first of maxima will be 2, because first is the 2 element whose value is maximum at 0.4. okay, next is what is last of maxima. How will calculate last of maxima? Just we will see from the reverse direction. For first of maxima we are seeing in this direction, last of maxima we will see in reverse direction. So if I move reverse, then 6 is not coming. 5 is the element whose value is maxima at 0.4. So last of maxima will be 5. Okay, so what this is about your first and last of maxima, but what about your mean of maxima? What about the other elements whose value is maximum at 0.4? What about that? For that we will calculate our mean of maxima. So mean of maxima is equals to summation of all the x elements divided by its cardinality. Okay, so what is that? So what are all the elements in your fuzzy set, in your x max fuzzy set? That is your 2, 3, 4 and 5. 2, 3, 4, 5. So if I do the summation of 2, 3, 4 and 5, I will get 14. Okay, I will get 14. Okay, 2 plus 3 plus 2 plus 3 plus 4 plus 5. I will get this equal to 14. This equals to 14 and divided by its cardinality. How many elements are present? 4 elements are present. So divided by 4. Okay, so 14 by 4 something I will get 3.5. So mean of maxima value will be your 3.5. Okay, so this is your maxima methods. Okay, so in the next video I will be discussing about your CENTROID method and weighted average method. Okay, so thank you for watching the video. If you like it, then share the video, subscribe to the channel. Thanks for watching. Thank you all.